barrel must be filled with solder. The other parameter inside the barrel of a through-hole solder joint is the wetting of the lead and barrel. Circumferential wetting defines how far around the lead and barrel wall the solder wets or connects properly. The minimum requirement calls for 1/2 or 180 degrees of circumferential wetting present on the component side of the lead and barrel. Next, let's turn to the solder side of the connection. There are 3 acceptable criteria. The first is the wetting of the lead, land, and barrel. The minimum acceptable solder joint should have a concave fillet with proper wetting for 270 degrees or 3/4 of the way around the circumference of the lead, land, and barrel. The second requirement for the solder side is contact angle. The ideal solder fillet will form a contact angle of 90 degrees or less. A contact angle of greater than 90 degrees is acceptable when the cause is the quantity of solder extending over the land. The solder joint is considered rejectable when the fillet is convex and the contact angle is greater than 90 degrees, but solder does not extend over the land. Another rejectable condition is when the solder clumps on the surface of the connection. Notice there is no feathered edge apparent and the contact angle is irregular. Our last parameter for the solder side is lead visibility. The minimum requirement occurs when the fillet is slightly convex with good wetting and the lead is not visible due to excess solder. You need to make sure you can see the lead in the barrel from the component side of the connection. This condition is called a process indicator, meaning the cause of the condition should be corrected in the soldering process. Now that you've been introduced to the concept of acceptance requirements, product classes, and soldering terminology, let's examine the acceptance criteria for Class 3 through-hole solder joints. The following examples will show the minimum and maximum acceptable dimensional and visual requirements for the 3 perspectives of a through-hole solder joint: the component side, the plated through-hole or barrel, and the solder side. Let's start by looking at the component side. The first parameter we'll examine is land coverage. The target solder connection will have a properly wetted fillet that covers 100% of the land and feathers out to a thin edge over the land area. It is allowable to have 0% land coverage on the component side as long as all other minimum solder coverage requirements are met on the barrel and solder side of the connection. The other parameter for the component side of the solder joint has to do with excess solder. The maximum acceptable condition allows the solder to extend up into the lead bend area as long as it doesn't contact the component body. Here's what it looks like when the solder actually touches the component. Now let's examine the acceptance requirements for the barrel of the solder joint. The first requirement we'll examine is the vertical fill of solder inside the plated through-hole. To evaluate this condition, you must look at the solder joint from both the component and the solder sides. While we've seen that the ideal or target connection has a slightly concave, cone-shaped fillet that rises from the outer edge of the land to the component lead, the solder joints you see every day may not always live up to this ideal. One common variation of the fillet's shape is a slight dip into the through-hole before the fillet rises onto the lead. This condition is especially common on the component side of the board, as gravity can cause the solder to sag slightly into the hole as it solidifies. As long as the solder joint meets all the other requirements for acceptance, some amount of solder depression is allowed. A maximum total of 25% solder depression on either the component or solder side is permitted. This means that a minimum of 3/4 of the barrel must be filled with solder. The other parameter for the barrel portion of the solder joint is the wetting of the lead and barrel. Circumferential wetting defines how far around the lead and barrel wall the solder wets or bonds properly. The minimum requirement calls for 3/4 or 270 degrees of circumferential wetting present on the component side of the lead and barrel. Next, let's turn to the solder side of the connection. There are 3 acceptable criteria. The first is the wetting of the lead, land, and barrel. The minimum acceptable solder joint should have a concave fillet with proper wetting for 330 degrees, or approximately 90% of the way around the circumference of the lead and barrel, and a minimum of 270 degrees, or 3/4 circumferential wetting over the land. The second requirement for the solder side is contact angle. The ideal solder fillet will form a contact angle of 90 degrees or less. A contact angle of greater than 90 degrees is acceptable when the cause is the quantity of solder extending over the land. The solder joint is considered rejectable when the fillet is convex and the contact angle is greater than 90 degrees, but solder does not extend over the land. Another rejectable condition is when the solder clumps on the surface of the connection. Notice there is no feathered edge apparent and the contact angle is irregular. Our last parameter for the solder side is lead visibility. The minimum requirement occurs when the fillet is slightly convex with good wetting and the lead is not visible due to excess solder. You need to make sure you can see the lead in the barrel from the component side of the connection. This condition is called a process indicator, meaning the cause of the condition should be corrected in the soldering process. Now let's examine the visual defect criteria for through-hole solder joints. We'll look at solder balls first. Any solder balls that are not entrapped in a permanent coating, or attached to a metal contact, or violate minimum electrical clearance requirements are considered a defective condition. Solder bridging is a connection of solder across conductors that should not be electrically joined together. This is always a defect since it misdirects the electronic signal. A solder cavity that does not reduce circumferential wetting of the lead and barrel, the land coverage, or the vertical fill below the minimum acceptable requirements is considered a process indicator. A void is an open area caused by air trapped within the solder joint. This is an allowable condition as long as the solder joint meets all of the other dimensional requirements. Voids are process indicators. Pinholes and blowholes are also examples of process indicators. Blowholes are larger than pinholes. They are created when heated gas escapes from inside the solder joint. You can identify a cold solder joint by poor wetting on the land and lead. Cold solder joints are considered defective because the solder connection will not reliably transfer electrical signals and may reduce mechanical strength. Occasionally, the coating on the component body will extend into the plated through hole during the soldering process. Component coating in the solder joint is a process indicator for Class 2 and a defect for Class 3. You can identify corrosion by colored residues or a rusty appearance on metallic surfaces or hardware. Corrosion is a defective condition. A disturbed solder joint is characterized by a gray, porous appearance with stress lines from movement of the solder while solidifying. This is always a defective condition because the solder connection will not be reliable. Now, let's look at the requirements for exposed basis metal on component leads, conductors, or lands. If the exposed basis metal comes from nicks, scratches, dents, etc., it is considered a process indicator for both Class 2 and Class 3 products. If the exposed material is caused by non-wetting, however, the non-wetting criteria would apply. This is what a fractured or cracked solder joint looks like. It's possible that a cracked solder joint will not allow the electronic signal to flow. That's why this condition is not acceptable. The next situation we'll examine is lead protrusion. Lead protrusion is measured from the top of the land, not from the surface of the circuit board. As a minimum requirement, the end of the lead must be visible in the solder joint. In terms of a maximum protrusion dimension, the lead end should extend no more than 2.5 millimeters for Class 2 products and 1.5 millimeters for Class 3 products, provided there is no danger of violating electrical clearance. For clenched leads, The lead protrusion requirements are the same as we just discussed for straight leads. It is also a defect if the lead is clinched toward an electrically uncommon conductor, reducing the remaining gap below the required minimum electrical clearance. Now let's look at non-wetting. Notice that the solder has not adhered to either the lead or the land. Complete non-wetting is a defect for all through-hole solder joints. Particulate matter on an assembly is also considered a defective condition. Assemblies should be free of dirt, lint, dross, and other particulate matter. Dirt or other residues might be electrically conductive and cause short circuits. Solder projections are undesirable protrusions of solder from a solidified solder joint. Protrusions are considered defects when they violate minimum electrical clearance and height requirements, meaning they could short out to adjacent conductors, or even an adjacent assembly, or the metal chassis when placed in the final system configuration. It's important to be aware of solder projections since they can pose a safety hazard. Visible residues from cleanable fluxes or any active flux residues on electrical contact surfaces are also considered defective conditions. In addition, the solder joint should be rejected if the metallic areas exhibit crystalline white deposits or there is a white residue on the surface of the board on or around the soldered termination. Solder splashes are a problem when they violate the required minimum electrical clearance. Solder webbing occurs when a film or splash of solder covers any area of the assembly that should be free of solder. Any solder splashes or webbing on the assembly is considered a defective condition for Class 2 and Class 3. This program has explained the workmanship standards for evaluating critical acceptance criteria for through-hole solder joints. Solder joint evaluation is a very important job in electronics assembly. When the criteria are not properly understood, the results are unnecessary touch-up and rework and unreliable products. Your careful attention can make a big difference in the production of high-quality electronic assemblies.